Here we will go over some of the basic rule of the exponential function. So first of all, I would like you to focus on this rule here, which is the basic rule of how we find the integral of e power x, which is directly e power x. The reason why, remember the derivative of ex will give you back ex. Now, this rule can be modified a little bit. Suppose we have a number 3 here. What will be the effect? What will be the answer? The answer will be, I'll just write for you the example. If there is a 3x, the e will be 3x, and because there is a number in front of x, you will need to divide by this. And this is just a simply result of the substitution method. Now, how about if there is number 5? It will be the same. 5, 1 over 5. How about if we have 7? You will have 7, 1 over 7. So, in general, if you have k in front of x, it will be kx and then 1 over x. And that's the rule up here. Let's see an example. So I'll just go to example number 1. If you have 2x, remember, it will be e2x, which is the same. This is and this are just merely the same. And then we divide by 2. If we have minus x, it will be again minus x, and then you divide by the number in front of x, which is just negative 1. Finally, if it is negative 2, it will be negative 2 here, negative 2 here. And that's all what we have up here. Let's see some more examples. We go to this question here. So in this example, the first step I will do, I'll expand the square. Remember, if you have a plus b squared, this will give you a squared plus 2ab plus b squared. That's what you should get, which means the first square, second square, and 2 times first times second. So in this case, you will have e squared, so it will be 2x, plus the second square, which is 5, it will be just 25. And then you will have 2 times 5 times ex, which is 2 times a times b to this 5 times the first times the second. You will get 10ex. Now I can find the integral easily. Remember, the integral of 25, because it is only a number, I just add x. Integral of ex, remember, it's just ex. Now, remember, integral of 2x, it will be the same, and then you need to divide by 2. So we'll get 1 over 2 e2x. And that's the answer for this question. So just to remind you what I did first step, I expand the square, and then I integrate each one separately. So here, expand the square. And then integrate each part using the exponential rule. Let's see example number 9, which is pretty much the same, except that we have to be here very careful. Remember, again, here we have a minus b squared, so you will get a squared, b squared, and then negative 2 times first times second. So let's do it. The first square, we get e2x. The second square, we get e minus 2x. And then we have negative here, 2 times the first times the second. Now, this one has a shortcut. Let me just try to go over it with you. It is e minus ex. Now, if you take e with e, this will give you x minus x. Remember, we just add the exponent. Now, ex, it will be e0, and e0 is just 1. So this, just write it down here, equal to 1. So just let me write down everything again. e2x, this will be minus 2, and the last one will be the same. And now we just do the integration here. e2x, it is just half e to x, because we just keep the exponential the same, which is 2x, and then we divide by half. 2, we get 2x. This one, we keep it the same, and then we divide by negative half. So it will be plus negative half. I will write it in that way. And that's how we do the integration. So in this example, what I did, I expand the square first step. Now, after expanding the square, I noticed that this can be simplified because x with negative x, if you add them, you get 0. So you get e power 0, which is 1. 1 times 2 is just 2. And then I integrate each part separately and find the final answer. We go to example number 10, which we need to rewrite this function. The idea I will do here, I will split the fraction. We have seen this idea, but it's always important to keep it in mind. What do you mean by split the fraction? Take ex to each one in the numerator. So this will be integral of 1 over ex plus ex over ex. Now, this I can rewrite it again. Now, ex with ex, this is just 1. So here just write 1. Now, what is 1 over ex? I can rewrite it because I don't know how to do the integration. I will write it as e negative 1. Now the answer is easy. Now, this is the integration of e minus x, or negative x, plus what's the integral of 1? It's just x plus c. And that's the answer. So in this equation, what I did, I split the fraction. So each one will take ex. And then 1 over ex, it is just e negative x. Ex over ex just give you 1. Now, e negative x is negative e negative x. Integral of 1, just you get x back. Now, where we have reached. Sometimes we can use the substitution rule in order to find the integral of the exponential. Now, if you have a function and it is derivative here, this is a perfect situation where you use the substitution method. But there is a shortcut. If you have e power u, and then you have u prime here, which is the derivative, the answer will be just eu. So the answer in this case would be just e power f of x. That's it. As simple as this. Just make sure whatever inside the e, the derivative is there in the question. That's all what you need to know and all what you need to do. Once you have function and its derivative up here, just do the same function inside the e. Let's see what I'm just mentioned here in the following example. I'll go to this example. Now, remember, I have to look at this one and consider it as u. And then ask yourself, what is u prime? Just the one, you can see it here. The answer is negative 12x squared. Sorry, this should be square. Okay, let's go back. Take this one. Oh, just let me do it here. Just let me do it here. U equal negative 4x cubed. Ask yourself, what is u prime? Well, u prime, it will be negative 12x squared. Now, do I have negative x 12 squared here? The answer is not. All what you have is x squared. So you are missing negative 12. How can we fix it to get negative 12? The answer is very simple. You write negative 12, okay? And then you have x squared e negative 4x cubed dx. And then divide by negative 12. This, supposedly to be cancelled with this, so we get this back. It's like I'm adding or multiplying by something I need, and then I divide by the same thing. So I didn't change anything in the question. Why do we need to do that? Because now the answer is simple. This is just e u prime dx. And remember, this one we said the answer now is perfect. We have u and we have u prime. So the answer is just e power u. So you just keep the negative 1 over 12, and the answer is e, and we keep everything in the exponent. And that's the equation. Let me just repeat what I said. I looked at this equation, and I see that there is an inner function here. Now, this inner function, I will call it u, just for short. And then I checked what is the derivative of u. It becomes negative 12x squared. Now, in the question, I have x squared, so I'm missing negative 12. Now, to fix it, you will add negative 12, and then you will divide by negative 12. This is the same trick we did before in the power rule. Now this one is a perfect derivative, and this one u. Now, if you have this one u and this one u prime, the answer is just e power u. And that's how we get this one. Let's see this question. Well, this question is not clear yet, so what I will do, I'll keep x power 5, and now I will take everything up, so it will be just negative 3 plus 3x power 6 dx. Again, I hope that this should be u, and this should be kind of u prime. Let's hope that this is the case. If it's not, I'll try to fix it, but for now, let me just write u equal negative 3 plus. And now you ask yourself, what is u prime? Well, u prime, derivative of a 3 is 0. Derivative of 6 power, it will be 6 power 5. But there is a 3, so the answer will be negative 18 x power 5. Now, what do I have in the question? Do I have x power 5? That's good news. So I'm missing only negative 18, which is just a number. So I just add and divide by this number. So this will be equal negative 1 over 18 integral negative 18 x 5 e 3 plus 3x power 6 dx, which is now you have it u and you have it u prime. So the answer will be negative 1 over 18, and then you just write the e, and whatever inside the e will be the same. Don't change it. So it will be negative 3 plus 3x power 6 plus a constant, which is c. That's how we did it. Let me just go through it quickly here. First step, I take this e up, so it will become with a negative sign. Second step, I look at this one, the inner function. I call it u. And then I check the derivative, because I want to make sure that the derivative is sitting here, so I can use the shortcut I just mentioned. Now, the derivative is negative 18x power 5, so we just write it down here. The last step, we just need to divide by 18. And now, we reach to the situation where we have u and we have u prime. So what's the integral of eu u prime? Is just eu plus c. Let's go to question part 3, which is the same thing. The first step, I'll need to write down e with the negative here. Now, sometimes this you can even go further with it. Look what I will do. I'll take this minus and I will write it down inside the bracket. Something I just want to do it now. So you get negative 2 plus 3x power 6. And now just u will be the inner whatever inside the e, which is -2 plus 3x power 6. What is u prime? That will fix the question for me. It will be 18x power 5. Remember, I'm missing 18, so what I will do, I will add the 18 that I need. So I get a perfect u prime. And then I'll divide by this 18. Now, what is this? What it will give me? It will give me u and the perfect u prime. So what is the integral of u prime? Is, as you just guessed it will be the same as e power u. So you keep u, which is the inner function. And of course, you have 1 over 18. Let's see. And that's the question, which is similar to the previous question. Take the e up. I distribute the minus just for fun. This one, I will call it u. And then I found u prime. But I noticed that I don't have the 18. So what I do, I put the 18 and I divide by the 18. And now, what is the integral of eu u prime? That's the integration for the exponential functions.